Okay, so let's take a look at an example of ANOVA, analysis of variance. I've created a new variable, call it 6H, and what this does is it breaks up our population into 4 groups. The first 2 refer to men, and the bottom 2 refer to women, and what the H stands for is hypertension. So I'm going to look at hypertension, incident hypertension. And so the first group is going to be men without hypertension. The second, so when 6H equals 2, is men with hypertension. Then women without hypertension, and then women with hypertension. And what we'd like to do is find out whether there is a difference between these 4 groups. With respect to what? Well, I've defined a new variable, which is the logarithm of BMI. Remember, with the analysis of variance, we need to assume normality. So that's why I took the logarithm. It's closer to being normally distributed than the raw BMI. Let's take a look at what happens in these 4 groups. To help us do that, let's look at the box plot. Okay, so here's the box plot, and we can make it a little bit bigger. We have the men, 1 and 2 are the men, and 3 and 4 are the women, and then without hypertension, with hypertension, it looks like the BMI is slightly higher for men with hypertension. The same with the women with hypertension. Although it looks like this difference is bigger than that difference. So, and this is lower than that, and this is lower than that. So it looks like, but not quite at the same levels. So that's why I'm looking at them as 4 different groups. Let's see what happens if we take a sample from this population and see what story the analysis of variance will tell us. So we are going to, let's take a sample. Oh, what should we do? Say 25. But let's have 25 in each one. So by 6H. So this should give us a sample of 25 in each of the 4 categories. So let's do it. There we have it. Let's do our one-way analysis of variance. So it's one way, and now the outcome variable is log BMI1, and we want it by 6H. And let's ask for tab to tabulate what's going on. Here we have the results. So there's the command, and here we have the results. Now, we have 25 people, men without hypertension, 25 men with, 25 women without, and only 24 women with. So it's a little bit uneven. That's the luck of the draw. Now, we look and we see a 3.2, 3.3, 3.1, and 3.28, 3.16, sorry. Here is the analysis of variance table. Here's the tables we asked for. That gives us the mean and the standard deviation for each of the 4 groups. Now, here are the between groups. This line is the between groups, and this line is the within groups. And what we have here is the sum is the mean squared error. So that's the S squared for between the groups. Remember, we called it S squared sub B. And here we've got the S squared sub W. And here's their ratio. And the ratio is 4.63. So it's much bigger than 1. And in fact, what's the p-value associated with that? There it is. It's 0.0046. So this is highly significant. So this is saying reject. The null hypothesis was that mu1 is equal to mu2 is equal to mu3 is equal to mu4. And what this says is, nope, reject that null hypothesis. So there's our null hypothesis. And this says reject. Reject the null hypothesis. Now, there is a bit of a benefit to this also. It gives us the Bartlett's test for equal variances. This is a test for homoscedasticity. It's a little bit sensitive to normality, but there it is. It's a test for homoscedasticity. It's a chi-squared test, which I haven't told you what it means yet, but we'll come to that. In the meantime, just look at this probability here. Look at the p-value, and this p-value is greater than 0.05, so that means we do not reject the test for equality of variances. So we do not reject, which is good, which says our assumption of homoscedasticity seems to be consonant with the data. So there we have it.